Okay, I'm going to do a little bit of a quick review of the review from yesterday. So I'm not going to do all of them, but I'm going to kind of bounce around a few. So the first few problems are going to be where you're going to use those identities that I showed you on the blue sheet. So these ones right here. Here's just reciprocal, quotient, Pythagorean, and odd even, and you're going to try and simplify them down to one term if possible. So first order of business is what I recommend is you look there and you see if you can use the Pythagorean to simplify anything first. So in this case, secant squared x minus 1, secant squared x minus 1 is tangent squared x. So I can rewrite this first piece as tangent squared x. I can rewrite the second piece cosecant squared as cotangent squared x, cotangent squared x. So now we've knocked it down from 4 terms where we'd have to do like a FOIL thing to 2 terms. Tangent squared times cotangent squared. Now, if you know that these are reciprocals of each other, that's great because you can jump right to the final answer. If not, you convert them to sines and cosines. So this becomes sine squared x over cosine squared x. This cotangent becomes cosine squared x over sine squared x. And when we multiply those together, we got a sine up top and a sine down below. So those divide out to 1. Cosine up top, cosine down below, those all cross off. That tells me that that guy simplifies to 1. Next one, cosecant minus secant. Nothing is squared, so I can't use a Pythagorean. So what I need to do is I need to rewrite these in terms of sines and cosines. So cosine x is already written. So cosine x over 1 minus secant x. Well, secant x is 1 over cosine x. So now what I need to do is I need to find a common denominator. Easiest way you ever find a common denominator is you multiply the 2 together. So the common denominator here, is going to be cosine x. So what I need to do is I need to make that first term have a denominator of cosine x. So that means I need to multiply the denominator by cosine x. But in the world of common denominators, I'm going to go ahead and multiply the numerator by it because I got to keep the value of it the same. So cosine x times 1, when I do that, I get my cosine x in the denominator. Cosine x times cosine x gives me cosine squared x minus 1 over cosine x. And then have a common denominator, I can put them back together. That's a cosine x. Put it up top, cosine squared x minus 1. Now, this is a little weird, it's a little different. It kind of looks like this. 1 minus cosine squared minus 1. They're just the reverse, the inverses of each other. I changed the sign of the positive 1 to a negative 1, the negative cosine to a positive cosine. So what I'm going to do is change the sign here. Basically what I'm saying is if 1 minus cosine squared x equals sine squared x, if I multiply everything by negative 1, I get negative 1 plus cosine squared x equals negative sine squared x. Or just rewriting this, cosine squared x minus 1 equals negative sine squared x. So this guy becomes negative sine squared x over cosine x. There's nothing that can really simplify that. That's my answer. What else? Number 4. Number 4 is my negatives. Sine of a negative number, the negative comes out front. Secant of a negative number, the negative just goes away. So this becomes negative sine of x times secant x. And now I just go through the same process. Sine of x times 1 over cosine x. That becomes sine x over cosine x. That becomes tangent of x. I'm sorry, negative sine x, and that becomes negative tangent x. So it's negative tangent x. Last one on the front, convert this. Well, this first guy, 1 minus cosine becomes sine squared x. If I look at my Pythagorean, 1 plus tangent squared becomes secant squared x over cotangent squared x equals tangent to the 4th x. So now what I'm going to do is put everything, the rule is I never mess with something that's down to 1 term, so I'm just going to leave the tan 4 by itself. but I'm going to rewrite all of this stuff over here. So sine squared x times 1 over cosine squared x. And cotangent is cosine squared x over sine squared x. So realistically, that just puts these two guys together. And up top, I get sine squared x over cosine squared x. Now, when you divide by a fraction, it's the same as multiplying by its reciprocal. So I'm going to take that cosine over sine, I'm going to flip it over. It's going to become sine squared x over cosine squared x. Now, sine squared times sine squared, 2 plus 2, that gives me sine to the 4th x over cosine to the 4th x. And if you follow the same logic when we look at our quotient, sine over cosine is tangent, sine to the 4th over cosine to the 4th is tangent to the 4th. So this last line is tangent to the 4th x equals tangent to the 4th x, and I verified that. So the answer key is up online for the other ones, but I just want to kind of hit on a few that were kind of the ones that probably would be the tougher ones. Backside. Backside, what we're going to do is we're going to go ahead and we're going to do sums and differences. So what that is I need to figure out on this unit circle two things that will combine to give me 285, either by subtraction or addition. So if I walk my way around the circle, 285, 225, and 60. If I add 225 and 60, I will get that. So this is the same as sine of 225 degrees plus 60 degrees. And now what I'm going to use is I'm going to use the backside here. I'm going to look at my sines and the sine of the sum. Sine of 1 plus 2 of a plus b is sine a cosine b plus cosine a sine b. So this is basically sine a plus b, where a is 225 and b is 60. So this becomes sine a cosine b plus cosine a sine b. And I just rewrite this as sine of 225 degrees cosine of 60 degrees plus cosine of 225 degrees sine of 60 degrees. And now what I'm going to do is read my unit circle, and I'm going to look for what the sine of 225 is. Well, here's 225. Sine is the second part. It's the y part. So it's negative root 2 over 2. Cosine of 60, when I follow that same logic, is the x part. So cosine of 60 degrees, cosine is the 1/2 part. And if I follow along the same logic, this is going to be negative root 2 over 2, and this is going to be root 3 over 2. I'm going to read that off the circle. Now multiplying these, I multiply across the top, so negative root 2 times 1 gives me negative root 2. 2 times 2 gives me 4. Now I have negative root 2 times negative root 3. Negative root 2 times negative root 3 gives me negative root 6 over 4. Same denominator, so I can put them back together. There's a 4. It'll be negative root 2 minus root 6 over 4. That's my answer. And this one is just reading it backwards. So sine cosine plus cosine sine. When I'm looking at this, it's got the opposite one. So this is a sine one, because if you look at sines have opposite sines and cosine, cosine, sine. Cosine has the same, 2 cosines, 2 sines. So this is sine, and since it's a plus, it's going to be 140 degrees plus 70 degrees. So this is going to be sine of 210 degrees. And if I read that off the circle, 210 degrees sine, that tells me that this guy is negative 1/2. So look on the unit circle to see if you can find it possibly. Okay. Now I'm going a little fast, but I wanted to make sure the video wasn't too long. Just watch it a couple times if you need to. This last one is sine of a minus b. So according to my sheet, the sine of a minus b is sine a cosine b minus cosine a sine b. That's how I expand it out. Now, if we notice, I have cosine a. Cosine a is 3/5. I have sine B. Sine B is 12/13. 12/13. What I need to do is I need to figure out sine A and cosine B. So here's how we do this. We're going to use the following trig identity. Sine squared A plus cosine squared A is going to equal 1. That's one of our trig identities. We know cosine A. So what I'm going to do is I'm going to plug in 3/5 for cosine A, but that's 3/5 squared equals 1. So sine squared A plus 3/5 squared equals 1. That tells me that sine squared A plus 9/25 equals 1. I subtract 9/25 from both sides, and I get sine squared A equals 16/25. I take the square root of both sides. That tells me that sine A is going to equal plus or minus 4/5. But since A is in quadrant 1 has positive, positive. I know that this sine A is going to equal the positive 4/5. So I know that this guy is 4/5. And now I need to repeat that process to figure out B. Sine squared B plus cosine squared B equals 1. I know that sine B is 12/13. So I'm going to plug in 12/13 squared plus cosine squared B equals 1. 12/13 squared is 144 169ths plus cosine squared B equals 1. When I subtract 144 169ths from both sides, I'm going to get cosine squared B equals 25 169ths. Square root both sides. Cosine of B is going to equal 5/13 plus or minus, but again, quadrant 1, so I know it's going to be the positive 1. So that tells me that this is 5/13. So now what I'm going to do is I'm going to pick up my calculator. I'm going to type in that expression with all those fractions there, and I'm going to see what it comes out to be. And what it's going to end up being is that this is going to end up equaling negative 16/65 in my calculator. And that's the answer. So please feel free to use both, this blue sheet, the one with your unit circle. And if you want to make an index card, you can make an index card where you kind of put a couple examples on it just to give yourself some advice on how to approach it. The test will be tomorrow. It's 10 questions. It looks exactly like this. Good luck, and I'll see you in test day.